In this video, I'm going to show you how we can evaluate this limit in 3 different ways. And I love this because it really highlights how creative mathematics can be. Oftentimes we are taught there's only one way to solve a problem, but here you can see that you can be very creative and solve it in multiple ways. So for this limit problem, I do want to mention that the first thing I always try direct substitution. So if we were directly substitute in 2, we would have square root of 2 minus root 2, which would be 0, divided by 2 minus 2, which is also 0. So we get the indeterminate form of 0 over 0, which means we need to do some more algebra in order to be able to use direct substitution and evaluate this limit. All right, on to method number 1. Method number 1 I'm going to show you is multiplying by the conjugate. So what I do is I look at the part of the fraction that has the radical, in this case the numerator, and that is root x minus root 2. And we multiply both the numerator and denominator by the conjugate, which is root x plus root 2. The conjugate is always taking your expression and just changing the sign in the middle. Now, remember that this is okay to do in math because essentially I'm just multiplying by the number 1, which means I am not changing this problem. Now, don't forget that when you do a limit problem, you have to drop down the limit notation until you directly substitute. Okay, so for here, you will distribute the parts that do have the radicals, in this case the numerators, but I'm not going to distribute in the denominators, and I'll explain why in just a second. So here I'm going to put these in parentheses to remind myself that I am distributing. Root x times root x is x. Root x times root 2 is a positive root 2x. Negative root 2 times root x is a minus root 2x. And negative root 2 times positive root 2 is a negative 2. And then in the denominator, like I mentioned, I'm going to leave this in factored form. I'm not going to distribute out the denominator. And the reason for that is we do want, in the end, a factor to cancel. And if you leave this denominator in factored form, you'll see that factor canceled. So once again, I only multiply out the conjugate parts. Okay, and now I want you to look at the power of the conjugate. Here, positive root 2x and negative root 2x. Those are gone, and that is the power of that conjugate, which is why we utilize that strategy. We are left with x minus 2 in the numerator and x minus 2 times root x plus root 2 in the denominator. And that's why I mentioned keep that denominator in factored form, because you can see there is my common factor that can be canceled out, leaving me with the limit as x approaches 2 of 1 divided by root x plus root 2. And now we can directly substitute and can drop the limit notation. So here we would have 1 divided by root 2 plus root 2 is 2 root 2. And I'm going to go ahead and leave that unrationalized. But if you would like to see a video on how to rationalize the denominator, click here to see what rationalizing the denominator is all about. And also, if you're finding this video useful so far, make sure to give it a thumbs up and subscribe so that you can see weekly math videos. On to method number 2. And method number 2 is using L'Hopital's rule. And I also have previously recorded a video on L'Hopital's rule, and to see that video, click here. So L'Hopital's rule can be used when the limit as x approaches 2 of the numerator is equal to, you can see in this case, it's 0, and the limit as x approaches 2 of the denominator is also equal to 0. Therefore, L'Hopital's rule applies. And what that means is you take the derivative of the numerator and the derivative of the denominator, and the limit ends up being the same. So here we have the limit as x approaches 2, and to take the derivative of the numerator, I'm going to think about this as x to the 1/2, and that helps me use the power rule. So the derivative of the numerator would be 1/2 times x to the negative 1/2, and then the derivative of this constant negative root 2 is just 0. In the denominator, the derivative of x is 1, and then the derivative of this constant is also 0. I'm going to go ahead and write this in a little bit friendlier way. divided by 1, well, that can go away. Then I would have 1 over 2, and because this exponent is negative, I can move that into the denominator to make the exponent positive. So this would be x to the positive 1/2, which is the same as root x. Now I can use direct substitution and directly substitute in 2 to get 1 divided by 2 root 2, which is exactly the answer I got when I multiplied by the conjugate. And now on to method number 3. Yes, there are actually 3 ways you can evaluate this limit. And the third method is factoring. And I cannot claim credit for this method. I do want to say that this is inspired by one of my YouTube viewers, Jan. So thank you, Jan, for the inspiration of this third method, which is factoring. Now, when you first look at this limit problem, you may think, how do we factor this? And in fact, we are going to factor the denominator as a difference of squares. So just to quickly review what a difference of squares is, let me give you an example. If I were to factor x squared minus 16, this would factor into x plus 4 times x minus 4. It's a difference of squares. So what if now I had, for example, x minus 16? Well, I would have to take the square root of each of these terms, so this time it would be square root of x plus 4 and square root of x minus 4. So if I took that idea of factoring a difference of squares to factor this denominator x minus 2, let's take a look at what we would have. All right, don't forget to keep that limit notation. I have root x minus root 2 in the denominator. Okay, we're going to factor this denominator as a difference of squares. So if I take the square root of each of those terms, I would have square root of x plus, square root of, I forgot to take the square root of the second term, square root of x plus square root of 2, and square root of x minus square root of 2. And look at that. In fact, I'm really starting to like this method because right away I can see a common factor in the numerator and denominator that can cancel. So I'm left with the limit as x approaches 2 of 1 divided by root x plus root 2. Now I can use direct substitution and I would have 1 divided by root 2 plus root 2, which as we saw is 2 root 2. And I thought this was just an awesome method that Jan brought to my attention. All right, everyone, thank you so much for watching, and go out and use that creativity in math. And remember, there could be one problem such as this that you can solve in multiple ways. Make sure to give this a like and subscribe so that you can see weekly math videos. Have an awesome day, everyone.